scientific death.
Historians have noted that the inventor Thomas Midgley Jr. single-handedly impacted the Earth's atmosphere more than any other organism in history. Despite that legacy, his name has largely vanished from public memory. Midgley dedicated his career to addressing the most pressing, deadly technological hazards of the 20th century. In the 1910s, mechanical engineering faced two lethal bottlenecks. Automobile engines were destroying themselves from the inside through a violent mistiming called spark knock. At the same time, refrigerators relied on toxic explosive gases that frequently leaked, killing families in their homes. Society's demand for a fix set the stage for a man whose brilliant engineering solutions would inadvertently endanger the biological health of the entire planet. Midgley approached these complex chemical problems as a mechanical engineer, graduating from Cornell University in 1911. He joined a General Motors subsidiary, working for the inventor Charles Caring, who gave Midgley a critical task: stop engine knock. This forced an engineer to treat volatile chemistry as a predictable mechanical system. This framework allowed Midgley to innovate rapidly, but it created a significant blind spot for the biological consequences of his work. Midgley's initial attempts were chaotic, testing random elements that cured engine knock, but left an exhaust stench so foul he believed the public would never tolerate it. To move past trial and error, he turned to the periodic table to mathematically predict how different chemical families would behave inside a pressurized cylinder. He called this systematic search a foxtrot. By tracking properties downward toward heavier elements, he isolated element 82, lead. When combined into tetraethyl lead, or TEL, the substance worked. A small additive eliminated engine knock, cost very little to produce, and lacked the offensive odor of his earlier experiments. However, lead was already well known as a potent neurotoxin. Midgley succeeded in smoothing the combustion within the localized environment of an engine, but that success occurred in a vacuum, ignoring the reality of millions of cars exhausting an aerosolized heavy metal into the shared atmosphere. General Motors and Standard Oil formed the Ethyl Gasoline Corporation to market the additive. To minimize public concern, they branded the fuel simply as ethyl, omitting the word lead entirely from their pumps and signs. The human cost appeared almost immediately. Workers in the new manufacturing plants suffered acute lead poisoning, leading to hallucinations, insanity, and several high-profile deaths. To counter the negative headlines, Midgley held a press conference where he poured the liquid over his hands and inhaled the fumes for 60 seconds, insisting it was safe. He did not mention that he was currently recovering from a severe case of lead poisoning himself. Leaded gasoline allowed for more powerful engines and became massively profitable. This industrial utility ensured that corporate interests could override warnings from public health officials for decades. Following his success with leaded fuel, Kettering assigned Midgley to find a safe working fluid for the refrigeration industry. At the time, leaks from existing machines were still causing lethal accidents. Midgley applied his periodic table methodology again, calculating the trends for toxicity and flammability across the elements. He found the intersection of these variables at fluorine. The result was Freon, a stable, non-flammable gas that was safe for humans to breathe. It provided the industry with the non-toxic working fluid manufacturers had sought for years, making home refrigeration a standard reality. By the 1930s, Midgley was an icon of industrial research. He was appointed president of the American Chemical Society, having used rigorous engineering logic to neutralize the immediate, localized threats he was hired to fix. The consequences of Midgley's solutions remained hidden for decades, only revealing themselves long after his death. Leaded gasoline created a global epidemic of atmospheric neurotoxicity. By the time it was phased out, the exposure was linked to measurable reductions in global IQ scores and severe long-term health crises. This sequence of satellite data shows the growth of the Antarctic ozone hole between 1979 and 1992. Midgley's stable CFCs were reaching the stratosphere, where they reacted with ultraviolet light to actively destroy the Earth's ozone layer. Midgley treated the atmosphere as a mechanical space, an engine cylinder to be optimized, missing the reality that the planet is a fragile, closed biological system. At age 51, Midgley contracted polio, which left him severely disabled and confined to his bed. His engineering instinct kicked in one final time. He designed and installed a complex system of harnesses and pulleys to hoist himself in and out of bed. In 1944, Midgley became entangled in the ropes of his own design. He was found strangled to death by the machine he built to save him. Midgley remains a case study in brilliant, focused problem-solving. His career illustrates a profound warning. Technology optimized without a holistic understanding of its environmental impact transforms modern progress into a global threat.